ఓకే స్టూడెంట్స్, మరి లాస్ట్ క్లాస్లో మనము ఫస్ట్ ఇయర్లో వర్క్, ఎనర్జీ, పవర్ నుంచి 2 మార్క్స్వి ఎస్ఏ అటాచ్డ్ ప్రాబ్లమ్స్ ఏంటో చూసాం. మరి ఈ క్లాస్లో మనం ఆసిలేషన్స్ నుంచి కూడా మనకి ఒక ఎస్ఏ వస్తుంది, క్వశ్చన్ నెంబర్ 20గా. సో ఈ క్వశ్చన్ నెంబర్ 20 కూడా మనకి ఒక 2 మార్క్స్ ప్రాబ్లం యాడ్ చేయడం జరుగుతుంది. ఈ 2 మార్క్స్ ప్రాబ్లమ్స్ ఇంపార్టెంట్ ప్రాబ్లమ్స్ ఏంటి కొన్ని మనం ఈ క్లాస్లో డిస్కస్ చేసుకుందాం. సో దాంట్లో మొదటిగా ఒక ప్రాబ్లం చూడండి. On an average, a human heart is found to beat 75 times in a minute. Calculate frequency and period. యావరేజ్గా ఒక మనిషి సగటుగా ఒక మనిషి యొక్క హార్ట్ బీట్ అనేది ఒక నిమిషానికి 75 టైమ్స్ ఉంటుంది. అయితే మనల్ని ఫ్రీక్వెన్సీ, టైం పీరియడ్ కనుక్కోమంటారు. సో అది ఎలాగో చూద్దాం. చూడండి, చూడండి. సో ఫస్ట్ beat time is equal to 75 by 1 minute. So 1 minute means 60 seconds. Then it can be written as 1.25 seconds, or it can be, you can find out the frequency. Then it can be written as 1.25 frequency units Hz. Then you can write 1.25 Hz. Next, to find out the time period. Time period formula T is equal to 1 by frequency. 1 by frequency. So that is equal to 1 by frequency value 1.25. So 1 by 1.25, that is equal to 0.8 seconds. Time period, time units, seconds. So average human heart beat in 1 minute, that is the frequency, that is equal to 75 by 60. 1 minute means 60 seconds. So 75 by 60, that is equal to, we can calculate, we get 1.25. That is the frequency units, Hz. 1.25 Hz. Next one, we can find out the time period. The time period T is equal to 1 by frequency. So this is the time period formula. T is equal to 1 by frequency. Then you can write 1 by 1.25, that is equal to 0.8 seconds. 0.8 seconds is the time period. Take a screenshot. Okay friends, next problem manaki, what is the length of a simple pendulum which takes seconds? Suppose manaki general simple pendulum time period formula T equal to 2 pi to square root of L by. So it can be written as, or we can write squaring on both sides. Then write T square is equal to 4 pi square into L by G. Then it can be written, we can find out the length of the pendulum. Then remaining term we can take gt square is equal to 4 pi square into L. Then we can write L is equal to gt square by 4 pi. So this is the length of the pendulum. So which time is 2 seconds. Then we can time T is equal to 2 seconds, and G value is equal to 9.8. Then substitute these two values in this equation. You can find out the length of the pendulum. L is equal to, G means 9.8 into T square. So T square means 2 square, that is equal to 4 by 4 into pi. So 4 into pi square. So then you can write the 4 cancel, and remaining L is equal to 9.8 by pi value 3.14 into 3.14. Then find out the multiply 3.14 into 3.14, you will get the 9.8. So then cancel it, we get 1. So length of the pendulum is equal to 1 meter. So that is the answer. So length units meter. So that is equal to 1 meter. Okay, students. So once again repeated. So the time period of t is equal to 2.2 square root of L by G. So we can find out the length of the pendulum. Then we can squaring on both sides. T square is equal to 2 square 4 pi square. Square and root cancel. Then we get L by G. Then we can take G T square is equal to 4 pi square into L, where L is equal to GT square by 4 pi square. Then which time is 2 seconds? Then T is equal to 2 seconds and G is equal to 9.8 constant. Then substitute these two values in this equation. Then we will get the length of the pendulum. L is equal to G means 9.8 into T square means 2 square. 2 square means 4 by 4 4 pi square. So here 4 4 cancel. 9.8 by pi value is 22 by 7, or you can write 3.14. So 3.14 into 3.14 multiply, you get 9.8. So 9.8 by 9.8 cancel, then we get the L value 1. So the length of the pendulum L is equal to 1 meter. So take a screenshot. Okay, students, my next problem is again. A particle executes simple harmonic motion such that the maximum velocity during the oscillation is numerically equal to half the maximum acceleration. What is the time period? So, మనం find out చేయాల్సింది time period is clear. Next, so here one given important point, that is the maximum velocity in the oscillation is numerically equal to the of the maximum acceleration acceleration. So given that maximum velocity, so v maximum is equal to of the maximum acceleration. So this is the given condition. So V maximum is equal to half maximum acceleration. But you know that the V maximum is equal to A omega, and also A maximum is equal to A omega. Then you can write the A omega. Therefore, A omega is equal to 1 by 2. A maximum is equal to A omega. So here A omega square cancel. Then you can write omega is equal to 2. So next we can find out the time period. Time period T is equal to formula 2 pi by omega. So what is the value of omega? 2. Then substitute the 2 pi by omega value 2. So 2 cancel, then remaining answer pi. So time period T is equal to pi units. Sorry. So time period T is equal to units of pi k. The time T units ఏంటండి seconds. కాబట్టి time period T is equal to pi seconds. So this is the solution. So take a screenshot. మళ్ళీ ఒకసారి వినండి. మనకి క్వశ్చన్లో ఏమి ఇచ్చారో ఒకసారి చూడండి. Maximum velocity. So maximum velocity during the oscillation time లో is numerically equal. So numerically equal to half the maximum acceleration. So this is the given condition. Then we can write, but you know that maximum velocity is equal to a omega, and also same time maximum acceleration is equal to a omega square. Then we can substitute these two terms in this equation. Then a omega is equal to half a omega square. So we can cancel as the a and omega square. Then we can write the omega is equal to. So we can find out the time period. The time period formula t is equal to 2 pi by omega. Then you know the omega value, omega is equal to, that is equal to 2 pi by 2. 2 cancel, then you get the pi. So the time period t units is seconds. Then units is seconds. Take a screenshot. Okay, students. Next problem is a mass of 2 kg attached to a spring. A force constant 260 Newton per meter makes 100 oscillations. What is the time taken? ఇప్పుడు ఒకసారి ఆన్సర్ చూడండి. So you can, given that given mass is equal to 2 kg and force constant k is equal to 260 Newton per meter. Then find out the time. Time is equal to 2 pi into square root of m by k. Then you can write 2 pi into square root of m by m means 2 and k by 260. Then cancel the 2 1 ja, 2 3 ja, 130. So that is equal to 2. Pi means 3.14. Then we can write 1 by 1, or it can be written as 1 by root 1. So find out the this one, or we can calculate. We get the 1.55. So that is the time periods seconds. But you know the makes 100 oscillations. The 100 oscillations we can take the time. The 100 oscillations into time t. So that is equal to 100 into time oscillations 1.5. Then you get 50. Oh, sorry. So here 0.5. Then you can get the 55. So 55 seconds. So that is the 100 oscillations. What is the time taken? The time taken is 55 point something, 0.13 something. That is the 55 seconds. So this is the solution. Take a screenshot. Okay, friends. Mana next problem చూడండి. A simple harmonic oscillator has a time period of 2 seconds. Time period of 2 seconds. What will be the change in phase? 0.25 seconds after leaving the mean position. So solution given that time period t is equal to 2 seconds. And next one, what will be the change in the phase? That is given to the small t is equal to 0.25 seconds. So after leaving the mean position, simple harmonic oscillator of a time period of 2 seconds, what will be the change in the phase? Then you can find out the phase. Pi is equal to, phase formula pi is equal to omega into t. So omega means 2 pi by t into small. So that is equal to 2 pi by capital T means 2. The small t means 0.25. Then 2 cancel. That is equal to 0.25 means 1 by 4. That is equal to 5 by 4. So here we can write the units. And pi value is equal to 5 by 4. Phase units is radians. So pi is equal to 5 by 4 radians. So once again, given that time period t is equal to 2 seconds and phase time change is small d is equal to 0.25 seconds. We can find out the phase pi is equal to omega into t. Then omega means 2 pi by t into small t. Then we can substitute the capital T value to 2 pi by 2 into small t value 0.25. Then 2 cancel. Then here 0.25 we can write 1 by 4. Therefore pi by 4, the pi units is radians. Then pi phase value pi is equal to pi by 4 radians. Take a screenshot. Okay friends, my next problem. Calculate the change in length of a simple pendulum of length 1 meter when its period of oscillation changes from 2 seconds to 1.5 seconds. Length 1 meter. So, given that length L1 is equal to 1 meter and time T1 is equal to 2 seconds, T2 is equal to 1.5 seconds, or it can be written as 3 by 2. 3 by 2 seconds. Next one, we can find out the length L2 and also change in length. So that is your L2 minus L1. So we can find out these two. So we can take the one condition, that is L1 by L2 is equal to T2 square by T1. So here T2 is equal to 3 by 2. Then 3 by 2 whole square by 2 square. So that is equal to 9 by 4 by 4. So that is equal to, we can write 9 by 60. 4 4 is 60. So L1 by L2 is equal to 9 by 60. Or we can find out the change in length L2 minus L1. That is equal to 9 by 16 minus 1. Therefore, it can be written as 9 minus 16 by 16. That is equal to minus 7 by 60. So this is the change in length. So here calculate the change in length. So change in length, the increase or decrease. So here it can be minus, then the change in length is decreases from 7 by 16. So change in length decreases to 7 by 16. సో ఇక్కడ లెంత్ మైనస్లో వచ్చింది కాబట్టి మనకి ఏమవుతుందండి, డిక్రీజ్ అవుతుంది. సో ఎంత డిక్రీజ్ అవుతుందంటే 7/16 మీటర్స్ అనేది లెంత్ యూనిట్స్ ఏంటి, మీటర్స్, కాబట్టి 7/16 మీటర్స్ లెంత్ అనేది డిక్రీజ్. సో టేక్ ఏ స్క్రీన్ షాట్. Okay students, next problem. A clock regulated by a seconds pendulum keeps correct time during summer. The length of the pendulum increases to 1.02 meters. How much will be the clock gain or loss in one day? So time loss అవుతుందా or gain అవుతుందా ఈ సమ్మర్ లో ఒకసారి చూడండి. The correct time of clock T is equal to 2 seconds. Then T1 is equal to 2 pi into L by G, square root of L by G. That is equal to 2 pi into change in length is 1.02 meters and G value is 9.8. Then we can find out the calculate this one, we get the 2.0273 seconds. So increasing in the time period of each oscillations, T1 minus T, that is equal to 2.0273 minus 2. Then that is equal to 0.0273 seconds. So the number of oscillations made by pendulum keeping correct time in one day. So one day means 24 hours, 60 seconds and 60 minutes by t. Therefore, 24 into 60 into 60 by time t. That is equal to, we can calculate, you get the 4,000, 43,200. So therefore, finally you get the loss of time by clock in one day. So in one day, that is 0.0273 into 43,200. Then multiply both one, we get the 1,180 seconds. So finally, the loss of time clock in one day, that is 1,180 seconds. We take a screenshot. సో దీంతో మనకి ఆసిలేషన్ అనే లెసన్లో ఉన్న 2 మార్క్స్ ప్రాబ్లమ్స్ అంటే ఎస్ఏ అటాచ్డ్గా రావాల్సిన ప్రాబ్లమ్స్ అన్నింటినీ 7 ప్రాబ్లమ్స్ని మనం డిస్కస్ చేయడం జరిగింది. సో నెక్స్ట్ క్లాస్లో మనము సెకండ్ ఇయర్లో రావాల్సిన ఇంపార్టెంట్ ప్రాబ్లమ్స్ ఎస్ఏ అటాచ్డ్ ప్రాబ్లమ్స్ కూడా